Hey, how's it going? This is Mr. Hernandez, and I'm going to be going over this front side of the trigonometric function notes. The first thing you want to focus on is knowing that we're going to be using these three trig functions: sine, cosine, and tangent. And you can see here that the abbreviations are the three letters, the first three letters of those words. Now, these three trig functions are related to them, but we're going to disregard those right now. And so this other symbol right here is a circle with a line through the middle, and that is called theta. And so that's pretty much the main thing you want to know, those three things. Also, we're going to be dealing with right triangles, and that's the only way that we can use these trig functions the way we're using them. So I'm going to go ahead and draw a little box there to show a right angle. Now, the first thing I usually do is identify where the theta is, where that circle with the line through it is, and I'm going to draw a line going across. That is our opposite side. The other easy side is the longest side, which is across on the 90-degree angle, which is called the hypotenuse. So I'm going to label that one. And then the last side is the adjacent side. And so when you have these three trig functions, you'll be using this acronym called SOHCAHTOA. And so you have, I'll write it right here. You have S for sine, O and H is are the sides that deal with sine. And then you have the cosine, which uses A and H, which is the adjacent and hypotenuse. And notice those are the letters we're using here: adjacent, hypotenuse, right, and opposite, and so on. And then for TOA, that's TOA, which is tangent, and that's the opposite over adjacent. Okay, so this is something you probably recognized from last year, but this is a review, and it's always good to review because we're going to be expanding on this, but taking some time to practice. And so for sine, that is going to be the opposite over the hypotenuse. So the O and the H go here. Now the O in this problem is this opposite side, which is 3. And then the hypotenuse is the 5, the largest side, and that's pretty much it. So cosine, again, is the A over H, and that is going to be the adjacent, which is A, is 4, and the H is 5, so that'll be 4 over 5. And then tangent is going to be O, opposite over adjacent, O over A. So I'm going to put O over A. And then the opposite side is 3, and the adjacent side is 4. Okay, and like I said, we're going to ignore these other ones for now. But these are the main three. Okay, and the last type of scenario is when you're needing to find you want to know all three sides. And so if you're looking for a missing side, like this one, you'll need to know the Pythagorean theorem. And so, I might as well label this anyway just because we're doing that. So the longest side is the hypotenuse. The side across from our theta is the opposite. And then this would be the adjacent. And so there might be a trig ratio like the cosine or the tangent that would require us to know what this side is. And so we need to find it by using the Pythagorean theorem. And so that would be the These are both legs. A and B are legs. And then C is the hypotenuse. And so here the hypotenuse is 11, so I'm going to go ahead and replace this hypotenuse with 11. This is definitely one leg. That could be, let's say A, it doesn't matter. And then this could be our other leg, that could be B. So then I could say this would be 6 squared plus our unknown. And then 6 squared is 36, so we're going to simplify this. 11 squared is 121. And then we're going to solve for x by undoing PEMDAS. So because we have an exponent and we have an addition, we're going to do the opposite of PEMDAS and do the addition first. So we're going to get rid of this 36. And then we can go ahead and solve for, x by getting rid of this square by square rooting. And for what we're doing here, I would say leave it like this, unless it was if you put this in the calculator and got a perfect number, then you would use that perfect number here. But for this case, you could just leave it as a square root of 85. All right, well, I hope that helps you, and good luck on the back.